No worksheet today? Are you serious?
No.
Oh.
All right.
Why'd you put the S so far away?
Okay.
Mr. Petrio,
What?
why'd you put the E and the S so far away?
Who cares? Really? Is that like your biggest problem right now? Where the S is?
Hi.
Hi, Elizabeth. How are you?
Mad?
Yes, I am mad.
India.
All right. I'll write this out here. Why are you here? All right, so listen, balancing equations is something that usually you either get it real fast and it makes sense, or you just never get it and you just can't understand it forever. The reason we do balancing equations is because when we want to make something, we want to know how much we're going to make. And we also don't want to mix a whole bunch of one chemical and too little of another and have a bunch of stuff left over that gets wasted. So that's why we have to do this. Now, here's what happens. These are the reactants, hydrogen and oxygen in this case, and this is what you're making. This is water, right? So you start out with these things and you make this stuff. And however much you start out with is how much is going to get made, right? You can't make stuff more than you started out with. Now, the reason we have to do balancing is that we can't just have one oxygen and one hydrogen. Not everything comes in ones. Some things come in packages, and so we have to figure out how much is going to get used to make the other stuff. So I'm going to draw this out, and hopefully that'll make some sense. So our hydrogen comes as two hydrogen atoms stuck together. It's actually a molecule, and they always come in pairs. We can't just get one. And then it's the same thing for the oxygen. There's two oxygens stuck together. There's a double bond there, and they come in pairs. And this is kind of inconvenient because when you look at water, we need two hydrogen, but we only need one oxygen. So to make the water molecule, these two are going to bond to this one. And those three are going to stick together and make us a water. But we're going to have an oxygen left over. And so the question is, okay, well now what happens? Why do we have this oxygen left over and how do we deal with it? And so what has to happen is we need to find another pair of hydrogens, which are going to be somewhere hanging around. And these are going to react with the other oxygen. And since we need two pairs of hydrogens, we're going to put a 2 in front of here. And then this is going to make one water molecule, and this is going to make another. So we're going to end up making two waters. So we put a 2 in front of here. A different way to think about this would be, instead of making water, imagine if you were making bicycles, right? And every bicycle needs 2 wheels and needs 1 frame. But you go to the store and they sell you 2 wheels, but they only sell you 2 frames. You can't just buy one. They got boxes of 2 frames. Well, that's a problem. Now you're going to have to figure out what to do with that other frame. You're going to have to buy 2 more wheels. You're going to have to make a second bicycle.
You can wait for the first one to break.
These aren't going to break.
You have to spare.
All right. So you get the idea. You have to figure out how many of these are going to go with these to make how much product. You can't have anything left over because in real life there's not going to be stuff. I mean, you don't want stuff left over. You don't want to waste your chemicals. So that's why we need to make sure we got twice as much hydrogen so we can use up all the oxygen and make as much water as possible. The only thing that actually matters in here is these numbers. So remember that when you're doing these, I want to see these numbers. The drawings I'm doing to show you what's happening, but it's only those numbers before them that actually matters. 2 hydrogen. There's a 1 here. We're not going to write a 1. And 2 water. All right, questions? All right, let's do another example. And this time we'll show you how to do the math if it gets harder. All right, let's do potassium and oxygen, and this produces potassium oxide. This reaction will look a lot like when I threw the sodium and water. Well, this would be more like burning potassium. So you light it on fire, it's going to spark, and you make potassium oxide. Okay, and remember these numbers we can't change, right? The little numbers, nature decides those. We can't pick those. We can only put things in front of each of these. All right, so we got to balance this. So to do that, if it's not immediately obvious what you have to do, the best way is to make a list. How many potassium do I have before the reaction? How many oxygen do I have before the reaction? How many potassium do I have after the reaction? How many oxygen after the reaction? So this is how you're actually going to do all these to get what numbers go in front of here. All right, potassium, we have 1. Oxygen, we have 2. On the other side of the reaction, we end up with 2 potassium and 1 oxygen. So obviously that doesn't add up. And make sure your lists go in the same order, otherwise you'll confuse yourself. All right, so we look at this, and we just need to balance one element at a time. So which one should we do, oxygen or potassium? All right. You guys said both. I'm going to do oxygen because I know if I do that, it'll go faster. So there's 2 here, there's 1 here. So what do?
Add 1.
Right, I put a 2 in front of this. Now I have to put it for the whole thing. You can't just, stick a little 2 here. You're not allowed to do that. It has to be for the whole thing. So I put a 2 there. Now I have 2 oxygen, but now I also have 2 times 2 is 4 potassium. Okay, so I fixed oxygen, but I also changed the number of potassium. Now what do I have to do? Yeah, put a 4 in front of this so that I have 4 here. Now it's balanced. Once you have all these numbers the same for each element, then we're done. Question?
Nope.
Okay, let's do another one. All right, let's do, this will be methane, CH4, plus oxygen. This is a combustion one here. We're going to have CO2 and H2O are produced. One thing that may confuse you at first is there's oxygen in both of these, so as you're changing stuff on the right side, remember you'll have to add the 2 together. All right, let's make our list here. Carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. So we've got 1 carbon, 4 hydrogen, 2 oxygen. On this side we got 1 carbon, 2 hydrogen, and 3 oxygen, those 2 in that 1. So that's 3. All right, so obviously we're not going to touch carbon because that's balanced already. So we can do hydrogen or oxygen. Interesting thing about oxygen, there's 3 on the right side of the equation. There's 2 on the left. Right? This is O2. No matter what number I put in front of here, I'm going to get an even number. So I shouldn't really mess with this until I put an even number over here. So the question is, what can I do to make an even number on the right side? Yeah, I can multiply the water by 2. Put a 2 there. And that's going to change hydrogen and oxygen. Hydrogen will be 4. And the oxygen will be 2 times 1 is 2. Plus those 2, it'll be 4. Okay. So I put a 2 in front of the water. So I got 2 waters. That's 2 oxygens. Plus my carbon dioxide has 2 more. So 4 total oxygens. And the reason I did that is because I wanted an even number here because I know I need it to balance oxygen.
So you just added 12 together.
Yeah. Okay, now I got this done. Let's go over here. Let's put a 2 in front of here. That'll give me 4. And actually we're done there. Everything's balanced now. One thing to remember. This list isn't that important. This is to help you. What matters is these numbers here. That's all I care about. So you have to have those numbers. That's the whole goal. So don't make the list and just fill it in and not have numbers here because then you're just wasting your time. This is what we need to know. All right, we're going to do one more and then we'll be done. This is actually the one I was thinking of earlier. This is when, you remember we did the sodium in the water, we threw it in there, it made a big explosion. That's what this reaction is. Okay, so left side, sodium, hydrogen, oxygen. Right side we got sodium, hydrogen, oxygen. 1, 2, 1. 3 hydrogen, there's 1 there and 2 there. And then 1 oxygen. Oops, I put 0. Okay, the only thing that's not balanced is hydrogen, right? And again, this is a situation where I got an odd number here and water has a 2 in it, so that's always going to be even on that side. So the thing that I'm going to have to do is to put a 2 here so I can get to an even number of hydrogen. It's the only way that's going to get balanced. So that's going to be a 4. But remember, when I put this 2 here, it's going to change these things also, right? So that becomes a 2. That becomes a 2. And everybody gets why this is 4, right?
No.
2 hydrogen, the sodium hydroxide, plus the 2 over here. You got those 2.
We're still not the same.
It's not balanced, but I got an even number, because I know I'm going to need an even number on this side to do this. All right, so now what do I do? 2 in front of sodium. Yeah, go ahead. And then what am I going to do next? Put a 2 in front of water. That's going to be a 4, and that's going to be a 2. And now we're done. It's balanced. All right. Questions on this?
She said local something.
Wait, is that person here?
Yes.
Yeah, okay, so
Thank
Ms.
you.
Brooks is talking. Is my face
All right, we good?
Yep.
Okay, thank you.
Will you go over this with me?
Yes.
Because I'm not testing. Did you have a